hair can be a really important part of how we see ourselves, and that means losing it can be a stressful event. If you choose to embrace the naked dome, there are whole subreddits devoted to enthusiastically supporting you in that decision. But losing your hair can still feel like a really big deal, and the treatment options we have are limited and costly. Science is hard at work though, and a recent finding might crack our understanding wide open. And it's not just baldness. This research could lead to breakthroughs in how we understand how cells grow and divide, and that means a cure for baldness could help us study cancer. Here's why. Though we typically associate balding with men and older age, people of any gender and life stage can experience baldness. It can happen for a wide variety of reasons, but in a general sense, baldness is when your hair follicles stop producing hair. See, a strand of hair itself is not alive. It's basically a stack of dead cells surrounding a bunch of proteins, mostly keratin. Your hair is made by the living hair follicle, which sits in the middle to lower layers of your skin. To produce your luscious locks, hair follicles alternate between growing and resting in a process driven by a bunch of hair follicle stem cells. The longer the growth period, the longer the hair gets, and each type of hair on your body has different growing times. That's why you don't have to worry about your eyelashes or armpit hair growing 3 feet long. After the growth stage, the hair follicles enter a rest period in which the hair stops getting longer and eventually falls out. Then new hair cells fill in the empty follicle and the cycle begins again. Unless it doesn't. If no new hair comes to replace an old one that fell out, you get baldness. Technically, any type of baldness is called alopecia, although that term is mostly used in conversation to refer to the autoimmune condition called alopecia areata, when the body attacks its own hair follicles. Another type of hair loss is called androgenetic alopecia, commonly known as male pattern baldness. This is a largely genetic condition. Male pattern baldness is a bit of a misnomer. Androgenetic alopecia can affect people of any gender. It gives people with more testosterone in their body that typical M-shaped hairline that recedes over time, but people with more estrogen in their body tend to get more of a widening hair parts than a receding hairline. While your hair can sometimes grow back depending on the reason for the baldness, that may not be the case, and we don't really have any cures to prevent unwanted baldness for good. One of the most common treatments for baldness is minoxidil, also known by the brand name Rogaine. We're not fully clear on how exactly minoxidil works, but it seems to extend the growth phase of your hair follicles. It also possibly increases blood flow to the scalp, which helps to bring more nutrients to your hair. However it works, applying minoxidil to your scalp twice daily has been shown to slow down the rate of hair loss and increase the number of hairs per square centimeter in the early stages of hair thinning. Another common hair loss treatment, called finasteride, is a prescription pill that is only FDA approved for men. Finasteride works by preventing the testosterone in your body from converting into a different molecule that stops hair growth. Unfortunately, some men have reported some serious mental health side effects. Plus, it may increase the risk of developing prostate and breast cancer. Rosemary oil is an over-the-counter option, but the clinical evidence for its benefits is not rock solid. And of course, you could get a hair transplant. Transplants are considered to be a permanent fix, but they are much more complicated and expensive. So given the current options on the market, it's no surprise that people are very interested in identifying a longer-term solution to baldness. And we'll talk more about some new progress after this quick break.
Thanks to our presidents of science, Bino the Drunk Dwarf, Charlie Stanley, Harry Plumley, and Raz Taroche for supporting this SciShow video. They make it possible for you to watch these videos and learn for free. Our presidents of science work along with other patrons on Patreon and viewers who comment on videos and share them, all so that knowledge and curiosity can reach as far and wide as possible. The donations made on SciShow's Patreon pay part of the team's salaries, SciShow editors, producers, animators, and everyone else on the whole team who put together multiple high-quality, fact-based, and beautifully designed videos every week. And our presidents of science help that team make a fair salary doing all of that. And if you'd like to join our presidents of science in financially supporting it all, you could do that at patreon.com/SciShow.
In order to develop a treatment for baldness, it helps to know what's causing it in the first place. In 2025, a team of researchers looked into a protein at the center of this process called MCL1. MCL1 is a protein that prevents apoptosis, or programmed cell death. Since hair follicles go through apoptosis during their rest period, the researchers thought that studying MCL1 might reveal more about what exactly is going on during those rest cycles. So they did a classic scientist thing. To figure out what a protein does, get yourself some mice, and make that protein go away. The researchers removed the MCL1 gene in the skin of some mice from birth, and without MCL1 to keep apoptosis at bay, there was too much cell death. The mice were born with hair follicles, but they eventually lost their hair follicle stem cells. In another group of mice, the researchers suddenly switched the gene off when they were 55 days old and shaved a patch of hair from their mouse backs to see what would happen. The control mice, who still had working MCL1, regrew their shaved hair, but the ones without MCL1 didn't, and eventually lost all of their hair follicles by day 90. The role of MCL1 in preventing apoptosis seems to stop the follicle stem cells from dying, and it seems to be involved with more critical pathways than just hair growth. It interacts with a bunch of other important regulators that control the cell's life cycle, most notably p53. p53 is famous for its job as an anti-cancer regulator in your body. This protein protects you from cancer by controlling genes that boost apoptosis, which sends potentially problematic cells to their death. p53 is basically like damaged DNA, cellular stress, not under my watch, and boots those cells out. Or at least that's how it happens in my fanfiction. Christopher Nolan, hit me up. Among the many hats it wears, p53 also opposes the function of MCL1. p53 promotes apoptosis, MCL1 suppresses it, and under normal circumstances, these two proteins work together to keep hair growth under good control. It's like Batman and the Joker. It makes sense, Christopher Nolan! I know you're watching, my phone number is The researchers found that hair follicle stem cells get stressed if they're dividing fast, which signals p53 to switch on. So to find out what exactly p53 is doing here, it's time for more gene eliminations. This time, the scientists removed both the p53 gene and MCL1. And the mice without either p53 or MCL1 ended up with hair, even though not having MCL1 should have basically resulted in too much cell death and no hair. Removing the p53 coding gene rescued the mice's hairdos. This showed that p53 and MCL1 hold each other in check, and you need both in the right amounts to keep hair growth under control. As with almost anything in biology, balance is the name of the game. Now, even though we have found some of the key proteins involved in hair loss, translating that knowledge into treatments will still take a lot more research. We'd need to find a way to increase the activity of MCL1 somehow, and this research doesn't provide a way to do that yet. And by the way, switching off p53 entirely instead is out of the question. We cured your baldness, but gave you cancer is a complete non-starter. But finding evidence for the role of MCL1 in apoptosis, especially in stem cells, is a super important step in learning about cancer. Some people are interested in targeting MCL1 for cancer treatments if we can figure out how to carefully fine-tune its activity. Knowing how MCL1 impacts stem cells is also exciting for studying tissue regeneration. Since stem cells can turn into a bunch of different cells, finding a protein that could control them could mean being able to tweak which tissues are growing when. Even if we haven't found a cure for baldness yet, in the process of learning about hair loss, we have found another pathway that the body uses to control cell growth and cancer. And that could lead to potential breakthroughs that go way beyond the top of your head. So bald mice and bald men, hold your heads high, knowing that hair loss research has taken us another step closer to understanding cancer. And baldness too.